And when your exam will be conducted?
Sir, from October 23rd.
From October 23rd. I think just wait for 2 minutes, and I'm waiting for other students.
Okay, sir.
Till then, we can revise the topic that we have covered in the last class. So first, you should know what is the length formula. This is the length formula, and mirror formula is different from the length formula. Here is plus and here is minus. All the things will remain. Magnification produced by the lens. We are talking about the linear magnification. So magnification produced by the lens is given by the, see, this is the magnification, height of the image, height of the object. And magnification can also be given by the image distance divided by the object distance. Hello Martin, how are you? Is your internet connection is okay? Okay, so now I am starting. Now focus all of you on your screen. I am taking the numericals. And numericals are the most important part of this chapter. So first, to solve the numerical, read the numerical. What is the question? So they are saying a convex, and for that you should know first what is lens formula, what is the magnification of lens formula. You should know lens formula. I am just writing it again. 1 by V minus 1 by U minus 1 by U is equal to 1 by F. This V is the distance of image, where the image is forming, and distance of the image from the optical center. Okay, so this is the image distance. And this U represents the object distance. How far you have placed your object in front of the lens. Object distance. And a small f represents the focal length of the lens. Focal length of the lens. This formula you should know, and the magnification formula you should know. Magnification is represented by small m. This magnification is given by height of the image divided by height of object, and also image distance divided by the object distance. So this thing you should know. Now see the question. A convex lens of focal length 10 centimeter is placed at a distance of 12 centimeter from a wall. Manha, have we discussed this question earlier or not?
No, sir, we didn't.
We have done it.
No, sir.
Already? No, okay. So all of you now focus. Convex lens of focal length 10 centimeter is placed at a distance of 12 centimeter from a wall. How far from the lens should an object be placed so as to form its real image on the wall. And in the magnification, I think I have written one more point. So add one more point in the magnification. If your magnification is positive, then your image will be virtual and erect. Note it down. Your image will be virtual and erect. If your magnification comes out to be negative, then your image will be real and inverted. Just note down this point.
Hello.
Hello, Martin. Now getting my voice? I think your internet is not okay.
Yeah.
Okay, no problem. Just note down this. M represent the magnification. And one more point you can add here. Focal length of convex lens you will take positive always. And focal length of concave lens.
So is it minus V by?
Yeah. What Martin?
Is it minus V by?
No, 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 no. Minus B by U is in the mirror. In the mirror we have minus B by U. But in the lens we have V by U only. Okay. Got it?
Yes.
Like you can see, you have the mirror formula na here, lens formula. Here you have minus na. In the mirror formula you will have 1 by V plus 1 by U is equal to 1 by F. Okay. This is for mirror. Concave, convex. And in the magnification, the change will be when you are calculating the magnification, then you can write for the mirror. Suppose you are writing. Please don't confuse in this. Height of image divided by height of object, and this is equal to minus V divided by U. This thing is for mirror, and this thing is for lens. So see the difference in both the formulas. Okay. Just note it down and we will solve the numerical then.
Yeah, okay, done.
Hamna completed. Manha,
Yes, done, sir.
Arshia, you are saying that your mic is not working. So, okay. So now we will discuss the numerical. Hmm. This is the question. Concave lens we have. Suppose this is the not the concave lens. This is the convex lens we have. First, try to draw the figure. A convex lens of focal length is placed at a distance of 12 centimeters from a wall. So this is the convex lens, and suppose This is the principal axis, and this convex lens is placed 12 centimeter from a wall. This is the wall. This is the convex. So this distance is given as 12 centimeter, and they are saying focal length 10 centimeter, means focal length of this is 10 centimeter. We have to find how far from the lens should an object be placed so as to form its real image on the wall. So when you will place the object here or here, I don't know where I want where the object is. So when you will place the object, uh, you will get the image on this wall. So I am supposing that I have placed the object here at a distance of u from this lens. We have to find the position of the object. Suppose u is the position of the object, means from this lens or from this optical center, the object is placed at a distance of u. You can say this is your object. And what is your where is your image? Your image is on this wall. Your image is on this wall. So your image distance will be this distance, this distance, and this distance will be your image distance. So you can say your this distance will be your image distance. Now, and just a minute, and for the sign, what we will take here, this 12 centimeter, you have placed your object here, and the direction of the light will be this. The direction of the light will be this, because this object will give the light in this direction. So your image is here, so means you are moving in this direction. You are moving in this direction to measure the object distance, image distance. I have told you in the sign convention. So you are moving in the direction of the light. You are moving in the direction of the light. That is why this distance, image distance, you will take plus 12. And for this you will not take any sign. For the unknown quantity, we will not take any sign. Now apply the lens formula. This is wall. Apply the lens formula. 1 upon v minus 1 upon u is equal to 1 by f. 1 upon v is 1 by 12 minus 1 by u is equal to 1 by f. This is a convex lens, so focal length is also positive. This is 1 by 10. Just calculate this by yourself, all of you. Try this by yourself. So this will become, when you will calculate, you will get your answer u is equal to minus 60 centimeter, I think. Check the answer. Simply you will take the LCM and you can solve. It will become 1 by 12 minus 1 by 10 is equal to 1 by u. So here, from here you can calculate.
It's possible.
Okay. So the LCM will be 60. It will become minus 1 by 60. So you will get minus 60 centimeter. So this negative, what is this negative sign shows? Here is the negative sign we are getting. Negative sign means your object will be here, somewhere here, on the left of the length. Okay, means your this object distance will be 60. Your object is placed at a distance of 60 centimeters from the lens on the left side. Why left side? Because for measuring this distance, you will go in this direction, means in the direction opposite to the light, you will take this 60 negative. Okay. So you can write here negative sign. Shows that object is placed on the left of lens. This is the left of the lens and this is the right side of the lens. So your object is on the left and your image is on the right. After that, they are saying how far from the lens should an object be placed so as to form its real image on the wall. So there we have to only find here the object distance, nature and the position they have given already. Real image is forming on the wall. So this is the first numerical on this topic. So write down this numerical also and write down the answer of this. Then we will solve the next question. Everything will be given in the question itself, but you have to identify in a proper way.
So, sir, in every question, we need to draw this like.
No. If you can do without the diagram, then you can. But the chances of mistake will be increased by 50%. There is no need to draw the diagram. But when you will draw the diagram, your answer will be correct. The chances are more that your answer will be correct when you are drawing the diagram, because everything will be clear that time.
Yes.
But this is not necessary. If you can just imagine in your mind, then you can do without the diagram also. No problem.
Okay, sir.
Yeah. That sign convention I have told you, that sign convention was very, very important. Means when you are measuring the distance along the direction of the light, then you will take that distance negative. And when you are going in the opposite direction of the light, then you will take the distance as negative. Like here, this is the object distance. So for measuring this object distance, all the distance you will measure from the optical center. So you will move from this optical center in this direction. So that is why this u will be negative here. Just note it down.
You can scroll down.
Guys, should I scroll down? Arshia, Hamna, Manha, and Martin, Subhana Khan. You are new in this class,
Yes, sir.
so are you getting this? Means have you completed the reflection of light, or
Yes, sir.
so actually theory part of this I have done already in this class. Okay, and if you want that part, you can check the video lectures. Okay,
Okay, sir.
if you are getting confused, because the sign convention part I am talking to you, Subhana, because the
Yes.
sign convention part is very, very important. Without the sign convention, there will always be the confusion in solving the numerical. Okay, So
Yes.
if you are getting confusion, then you can check out the recorded lecture and you will get the sign convention video there, and then you can proceed. Okay,
Okay.
so I am just scrolling it down. Only remembering the formula will not help you. Sign convention will be equally important. Why? Because see here, if suppose I have taken this 12 as a minus 12, so the whole answer will change in that case, and you will get 0 marks.
It's plus 12 when it's convex, right?
What?
It's plus 12 when it's convex.
What are you saying?
When it's plus 12, it's convex, right?
Plus 12? No, no, no. That is not the way. Actually, they this is not decided by that you are saying. Means convex and concave is no relation with that. Okay. If you are measuring the distance, see here the sign convention. Okay. This sign convention is valid for all types of lengths. Whether for I have written here the spherical length. A spherical length means concave and convex both. Okay. So this sign convention will be followed. If you are measuring the distance, this is the direction, this is the object. So direction of light will be this, because the object is the source of the light. This object will give light in this direction. And always you will measure the distance from the optical center. So if you are going in this direction, means you are going in the negative direction of the light. It means your distance will be negative. Okay. And here, if you are going in this direction, means you are going in the direction of the light, then your distance will be positive.
Okay.
Image distance can also be negative. Anything can be positive, anything can be negative. Okay. Suppose here is a convex lens given like this here. See, here this lens was convex, and in the question it is given that the image is forming in this side at a distance of 12 centimeter. Then also you will take the this plus 12. Okay, you have to decide the direction with respect to the direction of the light. Okay, just note it down. Written all of you.
Yes,
Yes,
sir.
sir.
Okay, so now I am taking another numerical. Now see this question very carefully. They are saying if an object of 7 centimeter height, suppose this is the object having the 7 centimeter height. Object of 7 centimeter height is placed at a distance of 12 centimeter from the convex lens of focal length 8 centimeter. Find position, nature and the height of the image. Position, nature and the height of the image. If you are able to draw the diagram, then draw the diagram, because the chances of mistakes will be less in that case. So suppose this is your convex length and principal axis, and here somewhere the object is placed. Here the object is placed. This is your object. Your object is placed here. This is your lens, convex lens. And they are saying the height of this object is 7 centimeter. So height of the object is 7 centimeter. Okay. So can anyone tell me the height of the object will be, we will take positive or negative? Martin, what do you say?
Yes, sir. It's
We will
positive.
take, yeah. Why we will take the positive? We can take the negative 7 also, because your object is above the principal axis and you are measuring the distance in this direction. Okay, you are measuring the distance in this. Suppose your object is like this, placed like this. Then in that case, you will take the height of the object as -7 centimeter. But your object is here, so you are taking +7. So this is your object, and height of your object is this 7. 7 centimeter. And this object distance placed at a distance of 12 centimeters from the lens means this distance and this distance will be the 12 centimeter. You can say this distance will be the 12 centimeter. And this distance is equal to -12 centimeter. Why? Because this is the object and this will be the direction of the light. This will be the direction of the light. And for measuring this distance from the lens, you will go in this direction, means you are going in the opposite direction of the light. Then you will take this object distance -12. And focal length given as 8 centimeter. This focal length will be positive because this is a convex lens. In case of concave lens, you will take negative focal length. They are asking find the position, nature, and the height of the image. So first apply the lens formula, that is given by 1 by b minus 1 by u is equal to 1 by f. V is the image distance. We don't know. This we have to find. Object distance we know, -12. Focal length is 8 centimeter. Okay. Okay. So now this minus and minus will become plus 12. Okay. 1 by 12, I can write this as, this will become 1 by 8. So calculation part you all should do by yourself. 1 by 8 minus 1 by 12. Okay, tell me the answer, all of you. Take the LCM of this. Manha,
Yes, sir.
just calculate this.
1 minute.
Okay. Well, you should know calculation, means how to do the calculation.
Will it be 1 by 24
Yeah, you are right. Plus or minus?
plus?
You are right. So how we will calculate? We will take the LCM of 8 and 12. This will be 24. Okay. So 8 4s are, sorry, 8 3s are, and this 2s are. This will 1 by 24. And the image distance you will get plus 24 centimeter. Here is the plus sign this time. What the plus sign indicates means your image will be in this direction. Here, somewhere here your image will be. Okay. Plus sign means you are moving in the direction of the light. If this, suppose if this is minus 24, your position of the image is minus 24, means from here you will go 24 centimeter in this direction, means somewhere here your image will be, but this time your image is somewhere here. This is your image,
Okay.
image distance. So positive sign shows that image will be at the right hand side of the lens. So this somewhere here your image, somewhere not somewhere, means at a distance of 24 centimeter from the lens your image will be. So no need to draw this because, okay, now they are asking uh, position. We have find this is the position of the image. They are asking nature of the image. Nature means whether the image is real or whether the image is virtual, and nature of the image we can find with the help of the magnification. So for the, you will use the formula of the magnification, that is height of the image divided by the height of the object, and you have another formula, position of the image divided by the position of object. Now you do not have the height of the image, but you have both these terms, so you will use this formula. First calculate this. So the V, you have this plus 24, and what is U? U, you have minus 12. So put here the minus 12. This will become minus 2. Your magnification is negative, and negative magnification indicates the real and inverted image. I have just told you, real and inverted image, real and inverted image. If your magnification comes out to be positive, then you can say your image will be virtual and erect. Okay, okay, fine. Now another, they are asking height of the image. So height of the image, if we will use this thing, we can find the height of the image. Okay, so height of the image, I want to find height of the object. I know plus 7 centimeter, and this V by U is minus 2. V by U is minus 2. Okay, means magnification is minus 2 V by U. So instead of this V by U, either you can write this as plus 24, the value of this V, or U is minus 12. So this will become minus 2. So height of the image you will have minus 14 centimeter. And now here in the height, the negative sign shows that your image will be like this. I am showing here. Your image will be like this. Below the principal axis, your image will form. Below the principal axis. This will be your image. The distance is this height of the image negative means the image will be below the principal axis. Okay, sign have the very important role. So here you can say image is below the principal axis. And height of the image is 14. Okay, simply. So height of the image is minus 14, and image is real and inverted. This is the nature of the image, and this is the position of the image. So all things I have calculated. So your image will be at a distance of 24 centimeters. Okay, note it down, all of you. Martin got it?
Yes, sir.
Manha,
Yes, sir.
Subhana,
Yes, sir.
and Arshia. Okay, your mic is not working. Hamna. Okay. And when completed, you can ask me to scroll down.
Yes, sir. You can scroll down.
Focal length I have taken positive because this is a convex lens, and for convex lens I have written the focal length will be
Okay, show
positive.
the
Diagram.
yeah, diagram.
Okay, okay, just note it down all of you and take your time. I am not saying diagram is necessary, but I am saying that if you draw the diagram, the chances of mistakes will be reduced. If you know this formula now only, then you cannot solve the question. Your answer will be different every time. You will see that the answer is coming different. Answer is coming different if you will not follow the proper sign convention. For solving the numericals on the lens or mirror, first you should know the formulas. Formulas is very easy. Formulas are very easy. There are two or three, four formulas, and then you should know the proper sign convention, and after that you should know the calculation. While you are solving the numerical, read the numerical properly. Okay. Martin completed the diagram.
Yes, sir.
Okay, so I'm just scrolling down. Please write down fast. I have one more numerical, and that numerical is very easy. This small m is the magnification. Earlier also I have told you small m is the magnification. Given by height of image, height of object. If anyone want to ask uh, any question regarding this, then you can ask me. If you have any doubt, then you can ask me. Any one of you? Okay, fine. Fine. Completed everyone?
Yeah.
Okay, so I am calling.
Yes, sir.
Okay, just copy this. Written, all of you?
Yes, sir.
Yes, done, sir.
Yeah.
If anyone have not written, then you can tell me. Otherwise, I am moving to the next numerical. So next numerical is we have to write that. Just a minute. Hmm. This is okay. Very simple question. They are saying the magnification produced by the spherical lens. The magnification produced by the spherical lens. Spherical lens are of two types, concave or convex. We don't know what type of lens is this. Is plus,
That's
yeah, yeah. Okay, we will see. The magnification is given by plus 2.5, and they are saying what is the nature of the image. So I have told you, if your magnification is positive, first part, so you can solve very easily. If your magnification is greater than 0, or you can say positive, then simply you can say the nature of the image will be real and virtual and erect. Nature of image will be virtual and erect. And now they are saying the nature of the lens. Nature of the lens they are asking. So we have not studied, I think, till now the convex lens. Oh, sorry, concave lens. Okay. So the lens will be concave lens. Okay, just a minute. What is the meaning of the magnification? Magnification means height of the image divided by height of the object. And there is one more formula, V divided by U. So this formula you will apply here. So, so magnification is this, means height of image divided by height of object is come out to be plus 2.5. So you can say height of image is equal to 2.5 times of height of object. So you can say height of the image is greater than the height of object. Is it or not? Mana means this time na height of the image will be greater than the height of the object. From this expression I can say na.
Yes.
So you can say the image will be magnified. The image will be magnified. You can say. So your image will be magnified. Magnified means larger than object. So when you will get the magnified image, see here, see this first part. When you have placed the object between this focus and the optical center, then you are getting this magnified image. And also this is the virtual image. This is the only case where you are getting the virtual image and the larger than the object, image larger than the object. Okay. So you can say this is the first of all, you have a virtual and erect image, and that virtual and erect image is magnified. This case is possible when you have a convex lens. Nature of the lens will be convex, you can say. If you are getting a magnified image and that too virtual and erect, then only the convex lens can produce, because when we will study the concave lens, the image formed by the concave lens will be always diminished. Okay, that is why the answer will be convex. Just copy this. So no need to write this form, because there is a requirement of this form only. Height of the image divided by height of the object. We will study 3 rules for the concave lens. Then we will discuss the topics in the next class. Okay. Write it down. Sorry. Clear, Martin? This
Yes,
question. The thing is, na means that I am telling you a lot of things right now. Means m is greater than 0, then nature of the image will be virtual and that, and thing, this thing I have told you. So the thing is, if you are not understanding these things, so what you should do, if you are not able to get the things properly, you should do proper revision of your notes, because in physics this is the science basically, but this part is known as the physics part. So this part is interrelated to each other. Okay, if you do not know one thing, then the other things you will not get understood, means you will not get in a proper way. Okay, so that is why the revision is must.
okay, sir.
Yeah, so written all of you.
Yeah,
Yes.
yeah.
Yes, sir.
Subhana, you have written.
Yes.
Subhana. So I am now moving. Just wait for 5 minutes. I will not take more than 5 minutes. See this. Uh, Earlier we have discussed. I will take only 5 minutes. Earlier we have discussed that if we have a convex lens, so there are certain rules for the refraction of light. Now we have a concave lens. In case of convex lens, the rules were different. See, rules for image formation on a convex lens. So these are the rules. Three rules we have discussed for the convex lens. Okay. Now rules for the concave lens. These are the rules for the concave lens. So rules means how the light will behave after passing through the lens. This is the rule. So suppose this is the principal axis and this is a concave lens. Okay, concave lens. C represents the optical center of the lens. So here a light ray parallel to the principal axis is coming and is passing through the lens, and refraction is taking place, and this ray in actual is going in this direction. Actually this ray is going in this direction, but what we are doing, we are just producing this ray in the backward direction, and this ray, when we are producing in the backward direction, will meet at focus. Okay, will meet at focus. So you can say that a ray of light which is parallel to the principal axis of the convex lens appears to be coming, appears, see the word appear here, appears means not actually, appears to be coming from its focus after refraction through the lens. Okay, so this ray is looking like that it is, this ray is appearing that is coming from this focus. Okay, so this is the first rule. Second rule is, suppose you have a light ray and this light ray is passing through the optical center of the lens, optical center of the concave lens. Then in that case, this ray will go straight. This ray will go straight. So this is a rule same as that of convex lens. In a convex lens also you can say here, a ray of light which is passing from the optical center goes straight. Okay. So a ray of light, rule number 2, a ray of light passing through the optical center of the concave lens goes straight after passing through the lens. Okay. Now third rule is, okay, suppose a ray of light is coming like this. Okay. And this ray of light is coming from infinite. Okay, no problem. Not from infinite. This ray of light is coming like this. And if this ray of light after passing through the lens will become parallel, so it means that when you will produce this ray, the actual direction of the ray is this. Means this ray is coming like this, and after refraction, it is going like this in actual. But when you are producing this ray like this, you will get this ray. This will appear that this ray is going toward the focus. Okay, and it will become parallel to the principal axis after the refraction from the lens. So the ray of light going towards the focus of the concave lens, going towards the focus of the concave lens becomes parallel to the principal axis. Okay, becomes parallel to the principal axis after refraction through the lens. Okay. So here, if a ray of light is parallel, then it will appear that it is coming from the focus. And here, if a ray of light is appearing to going to the focus, then it will become parallel. So both these rules are just reverse. Just note down these rules, and then we will meet in the next class. All of you.
Okay, thank you, sir.
Have you written this?